So AMA can be created by means of two ways. One is through instance, another one is through EBS. So let us see how to do it. So I try to do it. So I am logging into the sign into the console. So AMI image related things will be there in the EC2 dashboard. So images, snapshots and instances. So I am going with the EC2 service. So as I discussed through instance, how we will be doing, like go to instance, and it has been already selected. You select it, and within the actions we have image, create image. So you will be having see here, this CBS external EBS is not being created, and this root device will be created as an image. So you have to give, you can give the image name, like it's Amazon machine image only, but it is a customized one, right? So EC2 one image. So if at all any description, you can give over here. So if you want to add a new value, you can do it. So you just do in your lab. So whenever you are doing, so now create image. So it has been request received, and click on close. So in the background the image will be created. So images, it is being created now. Okay, this is one type of creation, image creation, and another one is through EBS. So see here we have two EBS. So earlier I just gone with the instance, so that it has taken the root device but not this external. If you want it, you might have seen create, add volume to it, you can do that. And by means of this volume you can create image, but first you need to create a snapshot of it. So name, what I am doing, like I am giving some name, like EC2 one one EBS snapshot, right? And description, EBS from VBS volume I have created. So whenever you create the image from the EBS, you will be going like this. So you just go to snapshots, you will be having the snapshot. These snapshots are uh, you know directly by default has been created. This snapshot has been created just now. You might have seen this time over here. It's nothing but created by image. These two things have been created by image. So whenever you have created the image from the instance, automatically snapshots are being created. Okay, this has been completed. You just select this, and in the actions you just create image. Hope you understood, right? Now we will be discussing, like, let us assume that I have one instance. This is the instance, and you can see how much of space is there. See, this is the root device, and we have the EBS over here. Yesterday we have allocated 10 GB. If you want to make this 10 GB, like, if you want to increase this 10 GB, generally what you will be doing, pertaining to this, you will be having one volume, right? So 10 GB volume, this is the value. So to do that, first you take snapshot, create snapshot, and after that you attach some of the volumes to that particular snapshot. So in that way you will be adding some more space to the particular instance. So anyway, we will be discussing now about ELB, very simple scenario. So AMI creation can be done in two ways, and very simple. You just do that, and while creation of the snapshots, you just put some files into volumes, and you try to explore them, and we just do. Now, elastic load balance is another service in AWS. So it is a, we can say, like, uh, in the traditional methodology, we will be having load balancers, right? So the load balancers are nothing but we have F5 and Big Brother, Big IP, and iProxy. So many things are there, right? So like this, our ELB works. In this scenario, we will be learning, like, what are the features of it, what is ELB, and what are the features of it, and where we use, and what are the benefits, and what are the related services to it. So that we will be discussing. So first of all, what is ELB? Let us discuss. For example, I have two virtual machines, and the client is here, is the client. Let us assume that this is the client. So client is here. So to access this virtual machine EC2 instance, you need to give the URL, particular URL of this to this client. And to access this instance, you need to give this particular instance address or URL link. So two instances are okay. Let us assume that we have 100 instances. So all the 100 instances URL address must be knowing by this customer to access them. Very difficult scenario. For that reason, generally we will be having the load balancer. Another scenario is, let us assume that this customer is having two URL links, URL address. So he is trying to access this one, and he is not getting the response because this instance is busy. So he'll be trying, he does not know what might be the reason behind it, so he keeps on targeting this instance to access. So unnecessarily time based process will be occurring over here at client side. So client may lose. In the future there will be, clients will be losing if at all you are not responding to that particular customers. So for this reason also we will be installing the load balancer. So within the load balancer we will be having the URLs of the particular instances. Let us assume two instances, two links addresses, and 100 but information will be there, 100 systems, sorry, instances, information will be there. Whenever we create one load balancer, one unique address will be generated. That address will be given to customer. Using that address, customer will be accessing to this particular load balancer. It is its duty to find out which instance is ready, which instance is busy, so that it can direct that particular request to the available instance. For that purpose, in the elastic load balancer, we have health threshold and heartbeat mechanism and ping mechanism are there. Based on them, elastic load balancer will identify the active instance. Pinging interval mechanism also will be developing in the newer services. The ping mechanism is nothing but elastic load balancer will send one request. It pings to that particular instance. If it gets the response, ELB assumes that that particular instance is available. Every 5 seconds or based on your configuration, ELB sends one request, and if it gets the response, it assumes that the instance is ready to take the request. That we call it as heartbeat mechanism. So threshold values are configured values, and at that particular interval time it will check the instance's health. Based on these three scenarios, elastic load balancers will check the instance's states. Let us assume that this first instance is ready, so load balancer will be forwarding that request to this first instance. Let us assume that this is the important in the first instance important application is there. Let us assume that this is the application which is very important in first instance. So what we will be doing, like if we don't have the elastic load balancer, there will be more customers are coming, let us assume, for that application. There may be having a chance of crashing that particular instance, or there will be having a more load on that particular instance. Whenever load is high, the instance may not respond appropriately. So for this reason, generally what we will be doing, we install load balancer. So whenever you deploy the application in one of the instances, so ELB checks with the instances that are available, and the request will be forwarded to that. So instead of forwarding that particular request to only one machine, it forwards alternatively. So for that purpose we have two types of algorithms. One is random, another one is round robin. So random and round robin will be configured and weight values will be there. Based on those weight values, the first instance will be getting the higher weight valued instance will get the first request, more requests. So by these scenarios, load balancer will work like if you observe over here, load balancer will be distributing the traffic across multiple instances, two or more, right or not? So it distributes the traffic. So what is elastic load balancer? Elastic load balancer is nothing but it automatically distributes the traffic to the across multiple instances. So what is the use of it actually? If at all we install the load balancer. So whenever you install this load balancer, you will be having first and foremost thing is you will be having fault tolerance. So what is fault tolerance? So if one instance is down, so another instance will be serving for your purposes. So that we call it as fault tolerance. So generally in the scenarios like the server is unexpectedly down, so automatically with elastic load balancer will be redirecting that particular request to another active instance. The second scenario is sharing the work. 100 requests are coming. So simply ELB shares 50 to one instance, another 50 to another instance based on the algorithms. And by means of this ELB, we can achieve workload management and high availability. So what is workload management? So sharing the work across the instances is workload management based on the weight values and algorithm. High availability is nothing but if one is down, another will be able to process. So we can achieve both by means of this ELB. And we can have scalability option in better way. So what is this scalability? For example, I want to this application is having so many requests. So what I'll be doing? I want to attach one more instance. So you can simply do that, and to this instance, if you give the information of this load balancer, simply this instance will be configured to this load balancer, and whatever the requests that are coming to load balancer pertaining to this instance will be redirected. In the future, you don't need this particular instance because there is not much load. You simply delete that particular instance. There's nothing but ability to remove or add. So this type of scenarios we can have. So what is ELB now? ELB is nothing but it automatically distributes the traffic across multiple instances. By means of this we can have fault tolerance, workload management, high availability and scalability. So this is what elastic load balancer is. So what are the features that are there in this? Let us discuss about it. So the first and foremost scenario is if traffic is more, load balancer is able to distribute it right evenly. So controls the traffic. what is another feature, like for example, if you give these instances publicly, there may be having a chance of a malware intrusion, or some hackers will be hacking that particular thing. So this is outsider. Since the URLs are publicly exposed, this particular customer can directly access to it. Of course, will in the project we configure web server, but let us assume it is not there. So what we will be doing, we will be giving the IPs, we will have some IPs range, right? We will be giving the IP range over here, so that only those IPs can be accessible. And one more scenario, some people try to access through mobile. So that also we can restrict over here by giving the port numbers and protocols. So if that particular mobile is having that capability, then only they will be accessing. Is nothing but we can configure specific protocols and ports. You might have seen whenever we were creating that port number and IP address range, we have given the same thing over here. So another one is multi-AZ deployment is there. Multi-AZ deployment is nothing but if you configure this ELB, can be utilized across the availability zones. In different availability zones, we can configure load balancer to EC2. And there is no limitation while adding EC2. So unlimited or no limitation. So if you want to add 6 EC2 instances, you can, 10 you can. And there will be, AWS is providing automatically configured services to the ELB. Like some of the services like CloudWatch, auto scaling and Route 53 can be configured to this ELB very easily. So integrated services are already developed. So integration can be done in a smoother manner. And we can have security for this. How? We can have SSL certs or encryption methodology. So whatever you want, you can do at your end. So these are the features that we have. So we have integrated services, or some of the services that we can easily integrate. So those are nothing but we call it as related services. So what are the related services? Like whenever EC2 is there, then only you will be able to configure ELB. And auto scaling can be done easily. CloudWatch monitoring tool can be configured. Route 53 is another service for you know for networking purposes. So these will be readily available within the ELB. So for ELB, these are the related services we can say. So when comes to the types, there are, for now I'll be discussing like two types. So one is internal facing load balancer. So what is internal facing load balancer? So let us assume that I have two EC2 instances within the availability zone. Within the availability zone only we will be having the instances, right? So let us assume that I have two instances. What I'll be doing, I'll be creating the load balancer over here, and there is no internet required. So directly what we will be doing, internally we configure load balancer, that we call it as internal facing load balancer. Internet service, web service may not be available for this load balancer, but work will be the same. But the scenario is we have IPv6 addresses, right? It won't support because it is I mean to say, yeah, IPv6 addresses are available, but the thing is we have to have the private subnets. So you don't understand what exactly private subnets are. Whenever we discuss VPC, you will be understanding. Within the EC2, generally we will be having. Another scenario is we have external load balancer, like totally outside from the environment. So 90% of the things we will be using. So here internet service must be there to connect to these instances. So web service must be there. So this we call it as internet facing. So there are two types of load balancers, internal and internet, based on the architecture. So internet facing is does not support, as we discussed just now, IPv6 addresses just now we discussed, right? What are they we will be discussing in the VPC. So 99% we will be configuring internet facing load balancer. So let us see what are the uses. The uses already we discussed, like it will have a better fault tolerance. So fault tolerance is nothing but if one is down, another will be able to provide that particular response. For example, DNS failover is there. This ELB removes that particular load balancer endpoint temporarily or permanently. So it will remove unavailable load balancer at the endpoint. And another scenario is auto scaling is there. So what is auto scaling? We did not discuss about it. So most probably on Monday we will be discussing about auto scaling and another service. But in auto scaling also generally we will be having this ELB. If ELB is there, auto scaling will be performing in a better way. So just now we discussed, right, for we will be having the protocols and ports as well as SSL, HTTP, HTTPS. So what are the supported protocols are? The supported are like HTTP as well as HTTPS, and we have TCP and SSL. Ports will be ranging from 1 to 65535. So this is the limitation of ELB. And when it comes to the price, basic level is okay. So for the first 750 hours, it's free base for basic, and we pay So elastic load balancer will be transferring the data, right? Because from the customers to the endpoint, right? So for each 1 GB of data that has been transferred through ELB will be charged. And one more thing, if you are not using basic, for each 1 hour they will be charging. So there will be so much of hidden charges, so be careful. Now we discussed what is load balancing. It distributes the traffic across multiple instances. Why we need it? Because of fault tolerance, workload management, high availability and scalability. How we will be doing that? That we will be seeing now. So before going to it, I just want to discuss another two types based on the I can say architecture only. So it's nothing but there is horizontal load balancer. Another one is vertical. What is horizontal and another what is vertical? Let us discuss. So let us discuss what is horizontal. I try to discuss in see here. This is load balancer, and these are the EC2 instances. Let us assume that the customers are here, and from here request is coming to ELB. From ELB it distributes the work. So it is a single scenario, right? So this is called as vertical. In traditional methodology, we call this as vertical, but in AWS, it is called as horizontal. So we can add more EC2 instances and we can remove the instances as and when needed. It's nothing but grow and shrink as and when we need. And also, whenever you add or remove, we can call it as scalability is infinite. High availability will be there, workload management will be there, and scalability will be there, right? So this is what horizontal is. Then what is vertical actually? Instead of growing our EC2 instances, what I'll be doing, I'll be growing my EC2 resource. So let us see how. I have a EC2 over here. So let us assume that I have a RAM and something disk, hard disk, as well as some network cards. So for one type of customers, this configuration is okay. So customers are increasing. If customers are increasing, what I'll be doing to this EC2 instance only, I'll be adding one more disk to it, so that second type of customers or kind of requests also can be processed. Let us assume there is more load. I'll be adding another disk to existed environment. So this type of scenario we call it as vertical over here. So 99% we will be going with the horizontal only. Okay. So what are the scenarios for this load balancer and all we discussed just now, and how we configure it, we will be seeing now. Very simple. So to configure elastic load balancer, we need at least two instances, because it distributes the traffic, right? So go to EC2 dashboard. How many instances are there? I think only one. One running instance is there. But I have images, right? So I have one image available based on the EC2 itself, I think. And that is Linux. Other Linux is nothing but Amazon Linux. So what I'll be doing, this is EC2 one created image. It may take time, so don't get bored. So now this image, based on this image, I am trying to create another instance. So launch instance. So this AMI will be there within the my AMI. See here, AMI EC2 one. So where it has been created from the instance. What is the root device type? EBS. Okay. So I am selecting this. Nothing but based on the through the customized AMI, I am creating one instance. So the rest of the things I am keeping as same. So it is asking, do you want to add any new volume? So I am not adding anything. 8 GB is okay for me. This is EC22. Sorry. So I am adding another rule over here, like all traffic I am, okay, because the source needs to be CADR block grouped. For now, I'm just going ahead and launch. I'll be creating EC22 and launch instance. In the meantime, I'll convert it. EC2 sorry, EC22 pen. So this may be ready now. us go to instances. So there are two instances, EC22. Now I just discussed like 99% we will be going for internet facing load balancer, right? For that we need the service that should be exposed to internet. So what we will be doing, like we will be installing the web server in it. So I'm just installing the web server in it. So each and every system I'll access this instance now. So this is the public IP. So 50 and authentication. So EC22. This is EC22. So just EC2 user. Okay. Now I'll be logging into this one, EC21. So this is EC21. So this is EC21 instance. So first what I'll be doing, I'll be installing Apache web server in it. So let us see uh, to install it. So -y, so yum install httpd. So httpd generally says Apache. So why? Yes, so it has been completed. I installed this web server through root user. The same way we will be doing for this yum install httpd. Yes, so it is been there. Now what I'll be doing before starting this web server, I'll modify the index page. So this index page will be there within the root device. So already we are there in root. So we have var directory. Where is var? Yeah, this one. In the var directory, you just go to var directory. Within it, we have, yes, www. So go to it. Within that we have HTML, no? So go to HTML. So within the HTML, you will be having, okay, nothing, right? So what I'll be creating, generally in traditional methodology, we'll be having the index HTML page. So I am creating one. So what I'll be doing to create, whether we have in this, okay. So I'll be writing something like echo some within the heading. This is VC21, right? So what I'll be doing like VC21. I try to do this with echo. Permission denied. So okay, what we will be doing, we will be coming to the root directory. We'll be going with this var directory. We'll be creating. Will gives hyphen var directory. Oh shit. Okay, let us see. So So what is the explicit permissions giving? How to give that? Hyphen R only, no? Anybody knows about it? In recursive way. So for each and everything I have to give. I'll do one thing. 744 for this, and go to this. Then let's start. Okay. Go to by permission denied. Okay, sudo ch on 772 www. Okay, go to HTML is there. 7 HTML. Okay, so let us do now this. Let us see. So it is not coming because web server port hasn't been defined over here. So 8013F. So what we'll be doing? We'll be going for security groups. Here itself we will be doing. So all no. Okay. So this is not coming because the web server is not running. We'll start that web server. So to start it, start sorry service httpd start. Permission denied makes I could not bind address to 80. Permission issues, why I don't know. try to do this. Instances. Inbound, all traffic, outbound, all traffic. Then what happened? Anyway, we'll do this. Where is TCP? And HTTP 80. So the same problem. The ports are not listening actually, and another thing is permission issue. Let us see. Let us try for one more time. Why it is taking this much time? Okay, what we will be doing, like there are so many things are running with the 80 port in my laptop, like including Skype, and here itself we have 4 web servers in this laptop. So maybe that is causing the issue. Another one is permission. We will be seeing tomorrow. It's not a problem. So we just observe the theory part and forget about this what we call it as lab session, and we will be discussing the CLB as well as auto scaling and CloudWatch, 3 services on Monday. Okay.